7B.1, solving quadratics by taking square root. Here's a quality question and the learning target. If you need more time to look at it, please rewind and pause. Starting with the first equation. Just a quick reminder of what we did before spring break. So we want to find the key features. Here are our key features. Remember, this equation is the quadratic equation in standard form, which is the same as y equals ax squared plus bx plus c, where a is the number in front, and in this case the number in front of x squared is 1. The number in front of x is b, and c is the number with no variable, so 6. So we want to find these key features using a graph. So in your calculator, you are going to graph that equation, and it comes out looking like this. So we want to find the vertex, which in this case is going to be the very bottom. Go to Menu, Trace, Graph Trace, and go to the bottom of the graph and press down. It'll show us we have a minimum at negative 2.5, comma, negative 0.25. So we know we have a minimum. Our min and max always starts with y equals, and it's always the y value of the vertex, negative 0.25. Our axis of symmetry always starts with x equals, and it's the x value of our vertex, negative 2.5. So those three are always related. If you can find the vertex, you know your other two values. Our zeros. Earlier when we were moving along the graph with our trace function, we saw a 0 pop up right there. So a 0 is where this graph crosses the x-axis. One of our zeros is negative 2, 0. And then the other 0 is the other point where it crosses the x-axis. Oops, too far. Negative 3, 0. And our y-intercept is where it crosses the y-axis. We go up to the y-axis. There it is, y-intercept. It's at 0, 6. Other names for zeros are x-intercepts, solutions, and roots. So if it ever asks you to find any of those, it's the same as finding the zero. It's the same as finding your x-intercept. Just where does this graph cross the x-axis? Now, vertex form. So first I'm going to write out the standard equation underneath. It's a parentheses x minus h squared plus k. So we have everything we need in our key features. If we go back to our standard equation, we find a right in front of x squared. So a is our number 1. Parentheses x minus, our h and k come from our vertex. This is our h, this is our k. H is negative 2.5. When there's a minus, it becomes plus. And plus k becomes minus 0.25. Linear pairs is f of x equals a x minus p times x minus q. Now here we need to find a, p, and q. We already know a, it's 1. X minus, our p and our q are our zeros. So our first one is negative 2. Well, we have a minus, so it becomes positive. And then x minus negative 3 minus becomes positive. So this is our equation. These three equations are the same equation. This is standard quadratic, this is vertex form, and this is linear pair form. But all three are the same equation. So now what we're doing in this set of notes is we're solving this quadratic using the square root method. So here are the steps that we want to take. The first step is we want to make sure y is by itself. So in example 1, y is by itself. Step 1 is done for us. Step 2 is we want to replace y with a 0. This is the reason why we call one of our solutions or one of our x-intercepts zeros. Then we want to solve for x. In other words, we want to get x by itself. And once you get x by itself, you're going to take the square root. Well, you're getting x squared by itself. And when you take the square root, there will always be two answers. You'll see what we mean by that in here in a second. And then you can check your answer by graphing. That last one is very, very useful. Starting with step 1. Step 1's already done for us. Now we're going to replace it with a 0. 0 is equal to x squared minus 16. That was step 2. Step 3 is to get x squared by itself. To get x squared by itself, I'm going to add 16 to the other side. Now we have x squared by itself. Now we're going to do step 4. We're going to take the square root. And the reason we're taking the square root is because we want to get rid of this square. So we take the square root of x squared and the square root of 16. The square root and the x squared cancel each other out, leaving just x. And the square root of 16 is 4. But the second part of step 4 is there will always be two answers. Now the reason there's two answers is because there's a positive 4 and a negative 4. Now the reason that is, if we use this step here to check our answer, let's plug in positive 4 for x squared. Positive 4 squared is 16, which makes this equation true. But also, negative 4 squared is also positive 16. Remember, a negative times a negative is a positive. So both answers get us to positive 16, and that's why we have to include both answers. So our two answers are x equals 4 and x equals negative 4. Now what does this look like on a graph? If we graph our equation, x squared minus 16, we're looking for a 0, so we're looking for where this graph crosses the x-axis. If I go to menu, trace, graph trace, and go up to the x-axis where it says 0, I find my first one, negative 4. If I go to the other side, no, too far. I find the other one, positive 4. So your solutions are where your quadratic equation crosses the x-axis. Makes them really easy to find. So example 2. Step 1 is to get y by itself. So the only thing I need to do is move this 5 over. So y equals x squared minus 9. Step 2, replace y with 0. 0 is equal to x squared minus 9. Step 3, solve for x or get x squared by itself. To get x squared by itself, I just need to add 9 to the other side. 9 is equal to x squared. Now step 4, to get rid of that square, I need to take the square root of both sides. The square root and the square cancel each other out. The square root of 9 is 3. But what else does step 4 say? There are two answers, a plus and a minus. So plus and minus 3. Now, where do you think that's going to look like on our graph? Now, in order to graph this, we need to graph this equation. We need to graph the part that, or we need to graph after we get y by itself. So we want to graph x squared minus 9. Now we're looking at our x-axis. Where does this graph cross the x-axis? Our first 0, negative 3, 0. So that means x is equal to negative 3. And we have another 0. At 3, 0. So that means x is equal to positive 3. And those are our two answers. Example 3. So notice in example 3 we don't have a y. So we can't do step 1. So we're going to skip step 1. That means we're also going to skip step 2. Step 1 and 2 have to do with y's. There is no y. We can go straight to step 3. Solve for x or get x squared by itself. So the only thing we have to do to get x squared by itself is add 3. (24) is equal to x squared. Now we still have to do step 4. Take the square root, because we have this square we want to get rid of. So x is equal to the square root of 24, which is 4.898. But what does the second part of step 4 say? Oops. 4.898. The second part of step 4 says there's two answers, a plus and a minus. So x is equal to positive 4.898 and x is equal to negative 4.898. Alright, example 4, change it up just a little bit. So remember, f of x means y. So this is the same as saying y is equal to x minus 4 squared minus 25. So we have a y, that means we can't do step 1, get y by itself. Done. Step 2, replace y with 0. Now step 3, we want to solve for x, but x is inside parentheses. So I can't get into those parentheses until I get rid of everything else. So we can think of this as PEMDAS. In reverse order. So if we group PEMDAS, you always do parentheses first. Then exponents, multiplication and division go hand in hand, and so do addition and subtraction. So we're starting at the bottom and going up. X is inside the parentheses. So we want to see if there's anything being added or subtracted to the parentheses, which 25 is being subtracted from the parentheses. So we're going to add 25 to the other side. That's the first thing we want to do. Now we have nothing else being added or subtracted to the parentheses. Now we go to multiplication and division. There's nothing being multiplied out front. There's nothing being divided. So now we go to exponents. We do have an exponent, a square. Now we already learned how to undo a square, how to get rid of a square. And that's by taking the square root. The square root of 25 is 5. And now this square and square root cancel each other out, leaving just x minus 4. But what does the second part of step 4 say? Every time we take the square root, we always have a plus and a minus. Now this is where it gets a little weird. So we still want to get x by itself. To get x by itself, all I need to do is add 4, but I'm not going to add 4 directly to 5 just yet. I'm going to add it out front. And the reason being is because I'm adding and subtracting 5 at the same time. So that means 4 plus or minus 5 is equal to x. So here we're going to list our answers two ways. We have a plus and we have a minus. So we're going to call it the plus root. Which is the plus side of this. X is equal to 4 plus 5, which means x is equal to 9. And the minus root, which is x is equal to 4 minus 5. That means x is equal to negative 1. So here are our two answers, and if we graph this, if we graph it, our graph should cross at x equals 9 and x equals negative 1. Let's see if we did it right. So we're going to graph this equation right here. X minus 4 squared minus 25. Min, trace, graph trace. Our first 0, negative 1. Bingo. I think I went way too far. Nah, we always tell you guys not to do this. I went way too far. Up, still going. There it is. And our other 0 is at 9. So we got both of them. Awesome. Now example 5. Again, y equals x plus 3 squared minus 36. That's step 1. Step 2, 0 is equal to x plus 3 squared minus 36. Now PEMDAS in reverse. What's being added and subtracted to the parentheses? 36s. So I'm going to move that first. Now is there anything being multiplied, which is usually going to be up here, or divided? Nothing. Now we're going to move on to exponents. To undo a square, to undo this exponent, we square root. Those cancel, leaving 6 is equal to x plus 3. But we took the square root, so what do we need in front? A plus or minus. And to finish getting x by itself, I subtract 3, negative 3 plus or minus 6 is equal to x. We have two answers there. Plus root. X is equal to negative 3 plus 6. That means x is equal to 3. Minus root. X is equal to negative 3 minus 6. That means x is equal to negative 9. And if you want to make sure you get the right answers, just graph this and find your zeros. Step 1. Get y by itself. Y is already by itself. Y equals 3 x minus 2 squared minus 75. Step 2. Replace y with 0. Now remember PEMDAS in reverse. Anything being added and subtracted? 75 is. 75 is being subtracted from the parentheses, so we want to move that first. 0 plus 75 is 75 equals 3 parentheses x minus 2 squared. Now is anything being multiplied or divided to the parentheses? We have this 3 out in front. Remember, a number next to a parenthesis means multiplication. So 3 is being multiplied. We want to undo that by dividing 3. So 25 is equal to x minus 2 squared. Now do we have any exponents? We have this exponent right there. To undo that exponent, a square, we take the square root. Those cancel. The square root of 25 is plus or minus 5. And then x minus 2. To get x by itself, we add 2 in front of 5, or in front of the plus or minus. We get 2 plus or minus 5 is equal to x, our plus root. X is equal to 2 plus 5, x is equal to 7, minus root. X is equal to 2 minus 5, x is equal to negative 3. And you can graph that to make sure you did it right. Oops. So we're going to graph 3 parentheses x minus 2 squared minus 75. And we should have an answer at negative 3, 1, 2, 3. And a positive 7. 1, 2, 3, 4, 5, 6, 7. And you can use graph trace to get through that, but you're going to try to do this quickly. Now, example 7. Replace this with y. Replace y with 0. Anything being added or subtracted goes first. So subtract 36 to the other side. That's negative 36 equals x plus 9 squared. Now to get rid of the squared, we take the square root. But there's something different about this. The squared and square root still cancel each other out. Now the negative square root of negative 36. What's happening there? The square root of negative 36. That's not possible. It says at the very top, non-real calculation. So what that means is there is no real solution. And that is your answer for this one. You can't take the square root of a negative number. That's an algebra 2 thing. We're not going to get into that. So the square root of a negative number for us means no real solution. Okay. Example 8. Y is equal to x plus 3 squared minus 24. 0 is equal to x plus 3 squared minus 24. Anything being added or subtracted moves first. So 24 is equal to x plus 3 squared. Now I have nothing being multiplied or divided, so I'll move on to this exponent, the square root. Those cancel. The square root of 24. We took that earlier. Square root. Oops, you can't see that. Square root of 24. We're going to go to 3 decimal places. We take the square root, so we have a plus or minus. 4.898 is equal to x plus 3. To get x by itself, we subtract 3 out front in front of the plus or minus. And we get negative 3 plus or minus 4.98, or 898, sorry, equals x. So our plus root x is equal 4.898 which in the calculator negative 3 plus 4.898 is 1.898 minus root x is equal to negative 3 minus 4.898, which is going to be x is equal to negative 7.898. Here are our two answers. Alright, almost done. Y is equal to x squared plus 3x plus 2. Ooh, this one's very different from the other ones that we've done. So this is our standard quadratic equation, which looks a lot like ax squared plus bx plus c. Now, how is this different from the other ones that we've actually solved? Here we have two x's. We have an x squared and an x. For every other example, if you go back and take a look, we only have one x, either in parentheses with the squared, or without parentheses, but still just one x squared. So we can't actually use the square root method on example 9. We're going to have to use a quadratic method, which you're going to learn in a later section. So we're going to say cannot use square root method. Now, last example, example 10. What are the solutions to this equation? Now, what do you notice it's missing? The y. So we can skip the first two steps. There is no y to get by itself. There is no y to plug in 0 for. So we can skip those first two steps and start solving for x. So here, remember, PEMDAS inverse, do I have anything being added or subtracted to the set of parentheses, which means on the outside? I do not. But I do have a 3 being multiplied. To undo that multiplication, I divide. Those cancel, leaving x minus 5 squared equals 6. Now to get rid of that exponent, I take the square root. That's x minus 5 equals, because those cancel, plus or minus. Now, I'm going to leave it just for this example, I'm going to leave it as a square root of 6. Now, to finish getting x by itself, I need to add 5. But where am I going to add 5? You always move your last number in front of the plus or minus. So I'm going to add 5 right in there. X is equal to 5 plus or minus the square root of 6. Which the reason I left my answer this way is because that's how it's represented down here. Now, you can always turn your answer into a decimal. So the plus one, x equals 5 plus the square root of 6. That's the plus root. If you do that on a calculator, 5 plus the square root of 6. That is x equals 7.449. Cut it off at the third decimal. Now the minus root. X is equal to 5 minus the square root of 6. X equals 2.550. And there are two answers.